Hey trig class, let's look at one where we have to approximate because it's not an exact value or a value that's on the unit circle, so we're going to have to use an approximation. So once again, when we are using an inverse trig function to solve, we have to remember where they're defined. Inverse tangent, which I'm going to need here, is defined in quadrant 1. It's defined in quadrant 4. All right, in quadrant 1, it's the positive angles up to pi over 2. But in quadrant 4, we're looking at negative angles down to negative pi over 2. All right, the tangent of 0 is 0. The tangent of pi over 2 is infinite, or doesn't exist technically. The tangent here is 1. Okay, but knowing that this is going up towards infinity and this is going down towards 0, that lets me know that if the tangent's equal to 9, that it's got to be above the 45-degree line. So it's going to be above this value where it's 60. It's going to be somewhere way up here where the tangent is equal to 9. So let's just say that this is the angle that makes it happen. This is the angle that makes the tangent of that angle is equal to 9. All right, we can use inverse tangent to solve it as long as it's in quadrant 1 or 4, and it is. All right, now tangent takes on every positive value between 0 degrees and 90 degrees. 0, the tangent of 0 is 0. The tangent of 90 or pi over 2 is infinite. So it's making its way to positive infinity. So it's going to be able to hit 9. So that's going to happen in quadrant 1. Okay, but notice this says 0 to 2 pi. So where does it happen again? That's where you got to understand what tangent is. It's the slope of this line. That's why it's undefined when it's vertical. Vertical lines have an undefined slope. So that's a line, and tangent's the slope of that line. So if that's a line, just continue the line on. And notice we go into quadrant 3. And for this angle, the tangent would also equal 9. All right, now the next time it happened, if we rotated it again, we would have to go all the way to there. And now we're in above 2 pi. So it's just going to be these two angles. This is the first angle, and this one that goes all the way down into quadrant 3 is the second angle. How are they related? Angle 2 is equal to the first angle plus pi radians. All right, we're rotating 180 degrees because we have to stay on that straight line path. So that's how we're going to do it. We're going to use inverse tangent here to find the first angle, to find theta 1. Then we're going to add pi radians to it, and that's going to give us theta 2. All right, so inverse tangent, second tangent of 9 is the original theta that makes that happen. That is a positive number between 0 and pi over 2. And then to get the second one, I just add pi. So there are my two angles. All right, it wants us to round to 2 places, so that's going to be 1.46, comma, and then the next one 4.60. So there's the 2 places where it happens. So we just have to understand. It says to use a calculator to do it. We have to understand that that's the way inverse tangent works. All right, now another way you could use your calculator here. Graph it. All right, y1, the left-hand side, so y1 equals tangent. So instead of theta, you just do tangent x. All right, notice again the xt theta n, so that's fine to just press that button. And then the next one is the right side, y equals 9. All right, now I'm going to do my window, and I'm going to make it, because our interval is 0 to 2 pi, I'm going to make the small x 0, the big one 2 pi. All right, and I'm going to go up by pi over 6 again, because that gives us that smallest angle that's on the unit circle. And then my y minimum, because I have to go to 9s, I'm going to go down to negative 10 and up to positive 10, which is kind of the standard viewing window. I'm going to count by 2s here, and then there's my graph. So there's the tangent function. You can see that it hits our tangent graph twice in that window, and I could do second calculate to find where these intersections occur. So 5. There's my intersection. The first curve, it's saying, what's your first curve? It says y1 is tangent. I could also click down and go to y2, but my first curve is tangent. That's fine. My second curve is the y equals 9 line. And then it says to guess. So I'm going to move a little bit off over here to where this intersection is happening. So right about there, hit enter. So there's the 1.46. And then you have to actually go through the process again. So first curve again is my tangent curve. All right, my second curve is that horizontal line. And then I'm going to hit enter, and then my guess, I'm going to get as close as I can right about there. Hit enter, and there's my second, 4.60. So that's how I can use the TI calculator to help me solve that.